Welcome class. Hope you all are safe. Today the topic we'll be covering is to find out the coordination number of HCP and CCP arrangements and to find out the formula of a compound and number of voids filled. So let me start with my first topic to find out the coordination number in HCP and CCP arrangements. So you know what is the coordinate? What do you mean by coordination number? Coordination number is the number of nearest neighbors. So if I talk about this sphere, which is in layer A of HCP, you know in HCP arrangement we have AB type of arrangement and tetrahedral voids are being occupied. Now if I talk about this sphere of layer A and we'll try to find out the coordination number. So the number of nearest neighbors here are 1, 2, 3, 4, 5, 6. That is 6 in the same layer which are touching this central sphere of layer A and 3 in the above layer, that is layer B. So 6, 7, 8, 9. Total 9 and 3 below the layer A, that is 10, 11 and 12. So total number of spheres which are touching this sphere or the number of nearest neighbors in case of HCP is coming out to be 12. It means the coordination number in HCP arrangement is 12. Now we'll come to coordination number in CCP arrangement. If I find out the number of nearest neighbors in case of this layer C, you know in CCP arrangement octahedral voids are being covered and we have 3 layers and all the 3 layers are different and we have ABC type of arrangement. While in HCP it is AB type of arrangement. So now in CCP, if I talk about this layer and about this sphere, so I'll find out the number of nearest neighbors to this sphere. So it is coming out to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So of this sphere, which is in between, how many spheres are covering it? 3 below, 2 in the same layer, 1, 2, 3, 4, 5 and 7 in the above layer. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 12 spheres are covering this sphere or touching this sphere. So the neighbor sphere or the closest neighboring atoms or the spheres for this one is again 12. So the coordination number for both is 12. So as the coordination number for both is 12, due to this, we can conclude that the spheres are very close to each other and as they are closely packed, very little amount of space is left. That is 74% space in HCP and CCP arrangements is filled. Therefore, these two types of close packing are highly efficient as 74% in these crystals are filled or is filled. Next, we'll find out the formula of a compound and number of voids filled. When particles are closely packed in CCP and HCP structures, you know there are 2 types of void that are being generated. One is octahedral void and another one is tetrahedral void. You know the formula to find out the number of octahedral voids is they are equal to number of close packed particles and number of close packed particles is given by capital N. So number of octahedral void is equals to capital N number of close packed particles. Now number of tetrahedral voids is equals to twice the number of octahedral voids. Number of octahedral voids are n. So twice the number of octahedral void will be 2n. So the formula to find out the number of tetrahedral void will be equals to 2n. Now we'll see to ionic solids. Ionic solids which are made up of ions such as NaCl. Na positive is the cation and Cl negative is the anion. So when we talk about ionic solids, in this the bigger ions are the anions and smaller ions are the cations. So these anions will be the particles which will be forming the close packed structure, and on that is these are the particles which are present, which are considered as lattice points. So these will be forming the close packed structure, the bigger ions or the bigger anions, that is Cl negative, and the smaller ions, that is Na positive, will be occupying the void. There is a space left between the spheres or these particles. So cation will be forming voids and anions will be forming the close packed structure. Now this cation, Na positive, sometimes it is very small in size and sometimes it is little big, somewhat big. So if this cation is very small ion, then it will be covering tetrahedral void. And if this cation is a little bit big ion, then this cation will be occupying the octahedral void. So that's what I have written. Depending upon size of cation, voids are occupied depending upon the size of Na positive or the cation. If the size of ion is very small, then tetrahedral voids are occupied, and if the cation is big, then octahedral void is being occupied. Now, in a given compound like NaCl, I've just now told you, the number of tetrahedral and octahedral voids that are occupied totally depends upon the chemical formula of the compound. For example, NaCl. In NaCl is the chemical formula of the compound sodium chloride. So for that, the number of tetrahedral and octahedral voids will be different. While in case of CaCl2, calcium chloride, the number of tetrahedral and octahedral void will be different. That is, the number of tetrahedral and octahedral voids will be totally depending upon the chemical formula of the compound. NaCl will have different, CaCl2 will have different, PbCl2 will have different number of these voids. Now I'll discuss one question, very important question in for your board exams. What is the formula of a compound? In this, what is asked is the formula of a compound. Formula you need to find out. Now, what is the data given? In which the element Y forms CCP. CCP, or you can say it is FCC. You know what is the number of atoms in FCC? Number of atoms in FCC is 4. So, what is the formula of a compound in which element Y forms CCP lattice? Y is forming CCP lattice, and Y is forming CCP lattice. That is, Y is the anion which is forming the CCP lattice, and atoms of X occupy 2/3 of the tetrahedral void. You know what is the formula for tetrahedral void? For tetrahedral void, it is equals to 2n. N is the number of atoms of the anions. That is, N is the number of atoms of element Y. So, X is the cation, Y is the anion. Y is forming CCP structure and X is occupying the tetrahedral void. So, to find out the formula of tetrahedral void is 2n. 2 into number of atoms of CCP structure. So, 2 into number of atoms of element Y. So, or what is the number of atoms of element Y? As element Y is CCP or FCC structure, and we have find out the number of atoms for FCC, it is equals to 4. So, what is the formula? Number of atoms of element Y in CCP unit cell is equals to 4. Number of tetrahedral voids of atom Y will be 2n. That is, 2 into n is here 4 number of atoms. 2 into 4 is equals to 8. So, the number of tetrahedral voids occupied by atoms of Y is equals to 8. Now, next. Atoms of X occupy 2/3 of tetrahedral void. Atoms of X are occupying 2/3 of tetrahedral void. Number of tetrahedral void is 8. So, the number of atoms of X will be equal, number of tetrahedral voids of X will be equals to 2/3 of number of tetrahedral voids of atom Y. It is given atoms of X occupy 2/3 of tetrahedral void. Tetrahedral void is 8. 2/3 of tetrahedral void will be 2 upon 3 into 8. It is equals to 16 upon 3. So of X it is 16 upon 3 and of Y it is 4. So it is 16 upon 3 is to 4. Ratio of X and Y. 16 upon 3 is to 4. 3 goes up. 3 4s are 12 is equals to 16 is to 12 is equals to 4 is to 3. So the formula comes out to be X4 Y3. So formula of compound is X4 Y3. Okay, thank you.